Hello everybody, this is Mr. Joseph, and we're gonna take notes on solving special right triangles. So the warm-up would have been trying to find different ways to solve for this triangle. So looking at this triangle, one method that we can use is trigonometry. We know an angle, we know one side, so we need to know these other two sides. So we can call this C and we'll call this B. So in order to find C, we will do sine of 30 equals C over 16. 16 of sine of 30 equals C. And we will see that C equals 16 times sine of 30. And we get 8. So this side right here is 8. So since we know one of the sides now we could use Pythagorean theorem to figure out what B is. So we can do 8 squared plus B squared equals 16 squared. 64 plus B squared equals 16 squared is 256. We'll subtract 64. We'll get 192. And B equals the square root of 192. So there's different ways to approach this. We technically could just leave it as square root of 192. But a lot of times they'll make you simplify it. So I know this seems kind of random, but 64 times 3 is 192. And the square root of 64 is 8. So instead of writing the square root of 192, we can write 8 root 3. And I'll explain in a second why this is important to write it that way. You also could have wrote the decimal. This really depends what the question is asking. The big idea here is that you know that it's square root of 192. How to break it down is just thinking about perfect squares and what number 192 is divisible by. So this is one method to do this. All right, so I'm going to erase all this and show you another method. So for the purpose of this video, I'm not going to really get into the details of why this works. I am just going to show it to you. I have another video where I kind of explain where this ratio comes from. But somebody discovered when you have a 30, 60, 90 triangle that you can use this ratio. So what this is saying is if 30 degrees is right here, the opposite of 30 degrees is x. So this can be like any number. And the hypotenuse will always be twice as big as the side opposite of 30. So when we look at our example, we see 16. So 16 is acting like 2x. So 2 times what gives me 16? Well, 2 times 8 gives me 16. So that means the side that is opposite of 30 degrees has to be 8 because the hypotenuse is twice as large as the side opposite to 30. And now I'm going to highlight in pink x root 3. So the side that is opposite of 60 degrees will be whatever side is opposite of 30, which is 8 root 3. And I don't know if you recalled, but these were the same numbers that we got previously when we used sine and Pythagorean theorem to solve this triangle. Because it's a special right triangle and it's called a 30, 60, 90, we did not have to use trig or Pythagorean theorem. If we just remembered this, then this allowed us to do this problem quickly. And that's why it's called a special right triangle. So I'm going to scroll down and I'm going to show you two special right triangles that we're going to study in this class. So does everybody see how 30 degrees is here? And this is x. Opposite of 90 is 2x. And then opposite of 60 is root 3x. You can also write it like this. That'll probably be a little better for your notes. And then there is this 45, 45, 90 triangle, which says that these two sides are the same. So we're going to call them x. And then the hypotenuse will always be x root 2. So in your notes, you need to have this down 100%. And everything is going to come back to this. And I'm going to show you a whole bunch of examples. All right, looking at this picture, before I even start the problem, I see 45, 45, 90. So I'm just going to go ahead and take that little template, x, x, x root 2. Look at that, everybody. 4 root 2, x root 2. Those match up perfectly. So that means this is 4 and this is 4. We are done. Because this template matches that exactly. It's not complicated, nothing weird about it. It's a 45, 45, 90, aka an isosceles triangle. These two sides are the same. And since this is x root 2, that means that this x is the number there. Next one is a 30, 60, 90. Before I start, I'm going to draw my 30, 60, 90. 30, 60, 90. X, 2x, x root 3. I look at 4. 4 is opposite of the 90-degree angle, which is called my hypotenuse. So 4 is acting like 2x. 2 times what gives me 4? X equals 2. So that means that this side has to be 2, and this side is 2 root 3. All right, coming down here. Once again, people always ask me, how do I remember formulas so fast? Every time I do the problem, I just keep writing it over and over again until I get tired of it. As we can see, opposite of 45 is 5. Since this is also 45, we know that this right here is 5, and this right here is 5 root 2. Pretty quick, pretty easy once you get into the rhythm of things. All right, we were having too much fun, right? It was a pretty quick. Now we're going to run into a problem. So I'm going to copy this triangle up here. All right, now here's the issue. We see 60 degrees, and opposite of 60, we said is x root 3. But now I see the number 4. So how did we go from x root 3 to a 4? So one thing we should have clarified is opposite of 60 doesn't always have to look like x times root 3, because sometimes the math works out where it gives you like a nice number. So let's think about this. So x times root 3 magically became 4. So what that means is whatever our x value is, which is the one that's opposite of 30, it's probably something that has a square root. So all you do when you have a problem like this, when you have a number that doesn't match the format of the formula, just take the formula piece and set it equal to the number that's given, which is 4. In order to solve this, we're going to divide by root 3. So x equals 4 over root 3. So technically, I could go over here and just say 4 root 3. Because do we see that 4 over root 3 times root 3 gives us 4. And this is x, and that's the root 3 in the formula. So that's why that works. But we don't leave it as 4 root 3 because mathematicians are very particular about having roots on the bottom. So since we don't like having square roots on the bottom, what we end up doing is multiplying the numerator and denominator by root 3. this just allows the denominator not to have a square root, because the square root of 3 times square root of 3 is the square root of 9, and the square root of 9 is 3. So we end up getting 4 root 3 over 3. And I know you're probably thinking this is really not that much better than what we had originally, but it's just like a little thing that mathematicians care about. Also, when you're doing like Delta Math or online math programs, they like the answers to be rationalized, so they normally don't accept answers that have square roots on the bottom. All right, back to business. So all of this is acting like x, and we said opposite of 90 degrees, or our hypotenuse, is 2 times x. So this ends up being x root 3 over 3, because I took what was opposite of 30 and multiplied it by 2. All right? So let's try this one more time. So once again, I'm going to draw my triangle, 30, 60, 90, x root 3, 2x. So all of this is x. I know you're thinking, that looks like x root 3, but remember, whatever is opposite of 30 is considered x. So all of 3 root 3 is x. Opposite of 60 is x root 3. And isn't our x 3 root 3? So it's 3 root 3 times root 3, which is 3 times root 9, which is 3 times 3, which is 9. So this side over here, everybody, is just the number 9. Because remember, the one opposite of 60 is x times root 3, and our x is this part right here. And then our hypotenuse is twice as large as the side opposite of 30. So this is 6 root 3, and I'm done. This one is a little kinder because there's not rationalizing the denominator. All right, this one right here, same issue. So first of all, this one is slick because it just tells us that these two are congruent. So we need to know that this is 45 and 45 because it's an isosceles triangle. I'm going to go ahead and write my ratio out. X root 2. Do we all see that 16 does not look like x root 2? So what we're going to do is take x root 2 and set it equal to 16. Divide by root 2. And then multiply by root 2. So we have a whole number on the bottom. And root 2 times root 2 is root 4. And root 4 is 2. So we end up with 16 root 2 over 2. And then 16 divided by 2 is 8. So this is 8 root 2. And this is 8 root 2. And we are done. So this is pretty similar to this problem that we did over here with the rationalizing. All right. We got another one. So once again, this one is not too special. If this is 2 root 2, then the hypotenuse is 4 root 2 because it's twice as large. And the one across 60 degrees is x times root 3. And since this is x, 2 root 2 times root 3 is 2 root 6. Because when you have square roots multiplying each other with the same roots, you just multiply the numbers inside. All right, to our last problem, which is our challenge problem. So I hope you can see this is kind of a mixture of 30-60 90s and 45-45 90s. So looking at this problem, I noticed 12. So that means that x has to be 6 because, once again, if we do this, 30, 60, 90, x, 2x, x root 3. that means that this is 6 root 3. If that's 6 and this is 45, that means this is 6 and this is 6 root 2. And now it gets a little tricky because opposite of 60 is 6. And this is 30. So that means I need to do 6 equal to x root 3. X equals 6 over root 3. Rationalize it. So we get 2 root 3. So this is 2 root 3. And this is 2 root 3. So the question really does ask what is y and what is x. So we're pretty much done. It's not necessary to find the other two sides of the rectangle. Thank you for following along. There'll be some homework associated with this as well. Take your time watching the video, and there's also other videos like proofs of where the 30, 60, 90 formula came from and proofs for the 45, 45, 90. Don't be afraid to be curious. This video is more just telling you how to do it. Thank you so much. Have a great day.